Hello, it's me again. In this video, we'll talk about the technology that's called MC or multi-context VRF Lite, basically, which is a technology that kind of create virtual routing and forwarding, and this is focusing on Comware devices. We'll show you some config in this case. So what are the objectives here? Describe what is MCE as a feature, which is multi-VPN instance customer edge. Simply speaking, it is kind of divided the network into multiple layer 3 switches, if you like, and they are completely separated from each other. Describe the use cases, and then we look at some configuration in this case. So think about it like the normal VPNs. We have VPN instances that communicate across MPLS or some other infrastructure here, like VPN or client or customer equipment that are in VPN1 should be able to communicate with VPN1. VPN2 should be able to communicate with VPN2. Of course, there are some advanced features where you can leak traffic between different, and they can control what kind of leak is that. Now, in terms of terms, we're using the VRF, virtual routing and forwarding instances. This is a layer 3 isolation, if you like. That was initially introduced in MPLS layer 3 VPN. And then if you don't have to have MPLS, which is something that you can apply to your data center or to campus, to whatever, we call it VRF Lite. It's kind of a light version of the VRF, and you don't have to use MPLS layer 3 VPN. And we use the term VPN instance, Comware term for the VRF. So in Comware, we use VPN instance, and MCE is a multi-VPN instance customer edge, Comware term for the VRF Lite. So if we use MCE or VPN instance, that is the Comware terms. So this is kind of a representation of what this means to us. So we have different colors. We give different colors for the purpose of showing that it is completely isolated. So routing and switching and whatever functionalities in different customers are completely isolated. Any interface that is mapped to that specific VRF instance is completely isolated. And that can be also a sub interface or a loopback interface or a VLAN interface, a layer 3 interfaces, and so on. What products we support for that VRF Lite? We use Comware 5, older one, we don't really now nearly use it, or Comware 7 5900 series, chassis base as well, 12900, and so on, and then any routers, Comware 5 and Comware 7. There will be, of course, limitations. This is just an example of the maximums that we can have. Of course, for other products, you need to consult the data sheet for that product. Use case 1, we might have multi-tenant data center. We have multiple customers they communicate, or they use a data center. You then create an isolation, a complete isolation for each client, and then the traffic will be using the same infrastructure, but they are completely isolated. Campus with independent business units. So they can also have a guest network completely isolated, and probably have some other networks for other purposes, for other reasons, like VoIP. Applications might require streaming and so on. Any maybe dev project, DevOps, we can have their own VPN, VRF Lite. Use case, overlapping IP segment, sometimes maybe overtaking another department or company merging. There's a chance they might have overlap IP. We can create VPN instance or layer 3 VRF for each one of these segments, and they will be completely separated from each other. We use in this case what's called route distinguisher for that kind of distinction. Isolated management network. So you ideally would like to connect and manage your switches from the out-of-band management. So that could have been an out-of-band interface on the switch itself. But you can also create an isolated VRF Lite, if you like, into these switches, and then you are sending the traffic for management in a complete isolation from the data traffic. Use case 5, shared services in data center. You might have shared firewall, you have backup, monitoring station, and so on. You might want to allow some sort of communication between this shared resource and some other elements, so in a controlled manner, if you like. And then in this case, you are able to control the traffic and which traffic can reach where, basically, based on your capabilities. Now, if you look at so the configuration steps that we will follow will create, I'll show you how to create a VPN instance, one command, easy. Bind the interface, layer 3 interface, configure the IP to that interface because any settings on that previous to the binding will be lost, and then configure layer 3 IP. We will continue then, we look at the routing or dynamic routing, static and dynamic routing. So we'll show you the example here just to show you how to do these steps. So the first thing you're going to do, you're on the system view, that you're on Comware switch, that is user view, and then you go sys view or system view, you're on square brackets, that's in system, kind of global config if you like. IP VPN instance, and the instance name is case sensitive. You can see display, or you can view it by display IP VPN instance. It will list you the instance. Now display IP routing table VPN instance customer A. You'll see now the routing table is empty apart from these built-in interfaces, if you like. Now, so the routing table for that instance is now empty by default. Next one, we would like to configure a layer 3 interface. We're going to define that layer 3 interface. Can be a loopback, it can be a switch virtual interface for VLAN, it can be anything, it can be a physical interface, sub interface, and so on. So here we can see that display IP or display interface brief. That's the command in Comware that will display all routed as well as layer 2 interface. In this is a router basically. It has all routed interfaces. Now VLAN 10 is down, okay, because not mapped anywhere. Okay, so you will create the interface. You will create the interface, and you should not, if you had any IP settings or any other settings, that will be gone. You then bind it to the VPN instance, and you can verify this by display VPN instance name. Yeah, and you can see this is a single interface bound to the instance. Okay, now you assign an IP or any other settings, and then you can see that this is directly connected. Display IP routing table VPN instance. That's local interface. That's local network because we created that interface, and obviously that is the interface. Notice the /32, which is the interface. Again, we can configure static routes. So IP route static from VPN instance to go to that destination through that interface. And you can have a default route as well for that VPN instance. So customer A has that default route and have that static route. You can verify that by display IP routing table for the VPN instance. You can see the default and the static route, and I can ping, but I have to specify which VPN instance I'm pinging. And there we go. That should be also I can do trace route. Here also I can look into the ARP table for the VPN instance. That is a result of sending an ARP request and get a response for that request. You can, on the other hand, configure also dynamic routing. So in here, we will use OSPF. So we create a loopback interface 11, and we bind it to customer A VPN instance, assign an IP, and we're going to use it as a router ID for the OSPF process 1000 map to that instance. Area 0. Network is basically advertise everything here. That's what it means here. we can view display OSPF process 1001 that's mapped to the VPN instance customer A in our case, and we can look at link state database. You can look at the peer. Again, peers might not at all aware of instances, but your core switch normally will have the instances configured on them. And then we can see display IP routing table for that VPN instance. You can see whatever configured in that VPN instance. That is what I wanted to explain to you in this very quick video. And we talked about MCE features, use cases, and basic configuration. I would like to say thank you very much for watching this video, and I will see you in future videos. Thank you very much.